Alright, let's look at the practice exam 3, problem number 13. Alright, so we're going to look at the infinite series to see if it's going to converge or diverge. Alright, so part A, I'm going to do a divergence test. So we just take the limit of the sequence first, right, 2n over 1 minus 3n as n approaches infinity, right? So if you plug in n equals infinity, so the numerator goes to infinity and denominator goes to negative infinity. So we have to do something about that. So the trick is look for the highest term on the bottom, power on the bottom, which is the first power. So I'm going to divide top and bottom by n. Right? So we get, so you have a limit as n approaches infinity, right? Then 2n divided by n is just 2. 1 divided by n is 1 over n. And the negative 3n over n would be negative 3. Right? And as you can see that n approaches infinity, 1 over n approaches 0. So what's left is negative 2/3. Right? But this is not equal to 0. So which means that this guy is going to diverge by divergence test. Right. So in order for a series to converge, the limit of the sequence has to go to 0. Otherwise, we automatically know that this is going to be a divergent series. Right. So that was part A. And let's look at part B. Right. So this is a geometric series. And looks like a value is going to be, the first term would be, so a value is going to be plugging in the very first number, so it's going to be 5, because anything to the 0th power is 1. Alright, then our value in this case is negative 2/3. Right? So since absolute value of r is 2/3, which is less than 1, right, tells you that this is going to be a convergent geometric series. Right, so we know how to find the sum, which is a over 1 minus r. Right, a in this case is 5, and r in this case is negative 2/3. Right, so we get the 5 over, 1 is 3/3 plus 2/3 and 5/3. So 5 and 5 cancel out. Right, reciprocal 1/3 is 3. So the sum is equal to 3 and it's convergent. Alright, that's it. I hope that this was clear.